السلام عليكم ورحمة الله. كيف الحال يا شباب؟ مادة التحليل الهندسي شعبة 1. طبعا زي ما تعودنا المحاضرة الثالثة في الأسبوع دائما عندنا تسجيل، فبنستكمل فيها اللي هي المادة اللي بلشنا فيها الأسبوع هذا، واللي كانت عن اللي هو parametric equations of a line. اوكي. طيب، فكنا احنا هون اتوقع الاكزامبل اللي وصلنا له وصلنا لهذا الاكزامبل اللي هو كان معطيني البارامتريك equations ل two lines L1 and L2. كان مطلوب مني اني اوجد الانجل between the two lines. Okay, so we had reached this point in the last lecture, and we were asked in this example to find the angle between two lines L1 and L2, and we are given the parametric equations of L1 and the parametric equations of L2. The procedure was that we find a vector V1 that is parallel to L1, and then find another vector V2 that's parallel to L2, and then after finding the two vectors, we do the dot product between them, and if the dot product is equal to 0, then the two lines are perpendicular to each other, and if it's not 0, then we find the theta, or the angle between the two vectors. And whatever angle we get, it's the same angle between the angle that's between the two vectors should be the same angle between the two lines. Okay. Okay. Let's move on. Of course, here the angle the two vectors, like the angle should be taken to be plus minus, because if we take the angle to be the cosine inverse of 14 divided by the square root of 1769, the angle will be 70.6 degrees. So let's say this is vector V1 and this is vector V2. Okay, so the angle is 70.6 degrees. Okay, and from where we get the plus minus, here the vectors V1 and V2 okay, the vectors V1 and V2 that are parallel to line L1 and L2, we give them plus minus, because let's say this is L1. Okay, so the vector that is parallel to L1 could be this vector V1 or this vector. Both of them are parallel to L1. The same holds for vector V2. If this is L2, then this is the line. This could be V2 or this. So we give both V1 and V2 this plus minus sign. Okay, and when we want to find theta, we have this plus minus sign. One time we substitute for the plus sign and we get this angle, and the other time we substitute for the negative sign and we get this angle. Okay, so the two lines could be this way, okay, or they could be this angle, or they could be this way. Both results are correct. Okay. Now, on this page, we want to find the distance between a line and a point. We mentioned how to find the distance between a point and a line in the previous lectures, and we will mention it again now. We have two methods to find the distance between a point and a line. The first thing is that, let's say this is the point, okay, and this is the line we want to consider, and the distance between the point and the line is, when we mention the distance, we always mean the shortest distance, which is the perpendicular distance from the point to the line. So the angle of this D of this line should make a 90 degrees angle with the vector B, okay, or the line P1, P2. Okay, so the distance is always meant to be the shortest distance, which is the perpendicular distance, shortest distance, which is the perpendicular distance to the line. Okay, the first method is that we consider the cross product. So if we consider, so we know, given in the questions, always will be given the coordinates of P4 and P1 and another point on the line. So this is the line. We should be given at least 2 points on the line, it's like P1, P2, and we are given the point, the third point that is not on the line, and we want to find the distance D. Okay, so from P1, P2, we form a vector, we call it B. So let's say a vector from P1 to P2, we call it B, okay? And we form another vector from P1 to P4. So P1, P4 is another vector, we call it A, okay? Now we find the cross product between B and A, the cross product A cross B, and we find the cross product and we take the magnitude for the cross product. This should be equal to the magnitude of A times the magnitude of B times the sine of the angle between them, which is theta. Okay, now if we divide the magnitude of the cross product, divide it by what? By B, okay, we will be left with A sine theta. A sine theta, if we look at this, this makes a right angle triangle, okay? One of its angles is 90 degrees. So we can say that sine theta from this triangle, sine theta is equal to what? It's equal to D divided by the magnitude of A, okay? So A sine theta, D equals the magnitude of A times sine theta. So this is D actually, okay? So we remove this and we say D is equal, the distance is equal to the cross product between A and B divided by the magnitude of B. So this is one way on how to find the shortest distance between a point and a line, okay? The other method for finding D is as follows. If we analyze the vector A into its components, we can say A is equal to the vector addition of A sub B, which is the projection. So this vector A could be looked at as the sum of its components. Its components are as follows. One component is the projection onto B. So this is one component. We call it A sub B. And the other component of A is this component. We call it A perpendicular to B. Okay, so any vector could be analyzed into the summation of its components. One component is the component that's parallel to B. We call it parallel to B, plus the component that's perpendicular to B. So we can say here that A is equal to the component that's parallel to B plus the component that is perpendicular to B. Okay. So the component that's perpendicular to B is the same as D. Like if we say the magnitude of the perpendicular component is equal to what? Is equal to D. So if we can find the perpendicular vector, then we can find D. So we say that the perpendicular component to B is equal to A minus its projection onto B. Okay, the projection of A onto B, we know that. So we can say A minus this one, which is the rule of the projection of vector A onto B is as follows. So it's A dot A sub B. Okay. Or we can, yeah. So it's A dot A sub B along B. Okay. And we can write it as in this way. A dot B times B divided by the magnitude of B squared. Okay, so this way we can find the perpendicular component of A, and D should be equal to the magnitude of the perpendicular component. Okay. So this is method number 2 for finding the distance between a point and a line. Okay. 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 Okay, let's share the screen again. So, okay. Okay. Okay, we have an example now. The example says that let points P1 and P2 be given as as here. We need to find some multiple things. Okay, so the first thing is we want to find is the distance between P1 and P2. So we have 2 points. And we want to find the distance between these 2 points. This is something very easy. So let's put the coordinates of the 2 points. So P1 is given by, P1 is given 1, 2, minus 3. 1, 2, minus 3. And P2 is given by minus 4, 0, and 5. Minus 4, 0, and 5. Minus 4, 0, and 5. Okay, so the first thing we need to find is the distance. Find the distance between, between P1 and P2. Now, the thing that is asked for is the distance, and it's a scalar quantity. Okay, so if we were asked to find the distance vector, then we should find a vector, distance vector, or the displacement vector between P1 and P2. These are vector quantities. But if it is find the distance only, then that means it's the scale, the magnitude of the distance vector. Okay, so to find the distance, first we need to find the distance vector between P1 and P2, which is equal to what? Minus 4 minus 1 a sub x plus 0 minus 2 a sub y plus 5 minus 3 along the z, which is equal to minus 5 a sub x plus or minus 2 a sub y plus 8 a sub z. So this is the distance vector or the displacement vector. Now the distance d between P1 and P2 is equal to the magnitude of the distance vector, which is equal to 25 plus 4 plus 64. We take the square root, which is equal to 68, 88, 93. It's equal to the square root of 93. Okay. Which is equal to around, 9.64. Okay. Now for part B, we need to find what? We need to find the vector equation of the line P1, P2. The vector equation, the vector of equation of line P1, P2. Okay. So it's the same. We want to find a vector equation for the line that connects P1 to P2, which is the same as the distance vector, which is equal to P1, P2 is equal to RP1 is equal to RP1, P2, which is equal to the vector we found here. This one is equal to -5, -2, and 8. Okay. Number 3, we want to find the shortest distance between the line and a third point P3. Okay, so okay, part C, find the shortest distance between the line and point point P3, which is given by 7, 7 minus 1, 2. Minus 1 and 2. Okay, so we have this line, let's call it L. And we have this P3. We want to find the shortest distance between the point and the line. Okay, so to do this, we have 2 methods. Let's use the method of the cross product. Okay, so we form 2 vectors. The first vector goes, let's say we have P1 here and P2 somewhere here. Okay, so we form 2 vectors. Okay, the first vector is this one, we call it B, and this other one is this one, we call it A. Okay, so this is D. This is the distance we need to find. And this is theta, which is the angle between the 2 vectors. So D should be equal to what? Should be equal to the cross product between A and B divided by what? Okay. So the distance should be equal to the cross product of A and B divided by the magnitude of vector B. Okay, but first let's find A. A is equal to P3, P1, P3, which is equal to P3 minus P1. Okay, which is 7 minus 1, it's 6. A sub x, minus 1 minus 2, which is minus 3, minus 3 a sub y, plus 2 minus minus 3, which is equal to 5, plus 5 a sub y, a sub z. And B is equal to what? To the vector from P1 to P2, which is equal to what? Minus 4 minus 1 minus 5 a sub x, minus 2 a sub y, plus 8 a sub z. Now we have the 2 vectors, we can find the cross product. So A cross B is equal to what? We have 6 minus 3 and 5. And then we have minus 5, minus 2, and 8. Okay. This is equal to minus 24 plus 10, which is equal to minus 14. Minus a sub y 48 plus 25. 48 plus 20, 68, 73. Plus a sub z, we have minus 16 minus 15, which is equal to 30 minus 31. Minus 31. Okay. Now, after that, we need to find the magnitude of A cross B, which is equal to 14 squared plus 73 squared plus 31 squared. We take the square root of all of that. So we have 14 squared plus 73 squared plus 31 squared equals, and then take the square root. This is equal to around 80.54. Okay. And now we want to find the magnitude of B. Okay, the magnitude of B is equal to 25 plus 4 plus 64, which is equal to 88, 93. 93. Square root of 93 is equal to around 9.6. Okay, so D, the distance D is equal to 80.54 divided by 9.6, which is equal to 80.54, which is equal to 8. So the distance D is equal to 8.35. Okay. Yes. So this is the result we have just got. Okay. Now let's get to this new subject, which is the skew lines. The skew lines are defined as any lines that are not parallel and they don't intersect. So the skew lines again, let's get to the whiteboard. So let's say we have two lines, L1 and L2, okay? These two lines, let's say L1 is this way and L2 is this way. If these two lines are not parallel, and they don't intersect, there is they don't intersect because there is a distance between them. Okay. So these two lines, we call them skew lines. So L1 and L2 are skew because they're not parallel to each other and they don't intersect. They don't intersect. Okay, we can give an example to two lines to be skew. These two, let's say these two pins are two lines. So if we do like this, these two lines are not secure. These two lines are secure. Why? Because they're not parallel to each other. If they were like this, they're parallel. But like this, they're not parallel, and they don't intersect. Okay? They don't intersect. If we make them touch each other, then they intersect. But as long as they're not touching each other, then they're not. They don't intersect, and we call them secure. Okay. Let's have an example to show the physical meaning of secure lines. Okay. So in this example, we are given two lines. Okay, L1 and L2, and we are given the parametric equations for each line. And then we are asked to find out if these two lines are parallel, are orthogonal, and if they intersect, and then decide, number 4, decide if they're secure or not. Okay, so let's get to the whiteboard. So, example, we have L1 with the parametric equations as follows. So x equals 4 plus 2 alpha. Four plus 2 alpha, y equals minus 5 plus 4 alpha, and z is equal to 1 plus 3 alpha. These are the parametric equations of the first line. Now for L2, x is equal to 2 plus beta, y is equal to minus 1 plus 3 minus 1 plus 3 beta, and z is equal to 2 beta. Okay, the first thing, decide. We want to, the first thing we need to find out is to decide whether the two lines are parallel. So decide if L1 and L2 are parallel. Okay, to find out if the two lines are parallel, what we need to do is we want to do a cross product between them. Okay, because if the two lines are parallel, that means the angle between them is 0. And if the angle is 0 and we make a cross product between the two lines, then the cross product should give me a result of 0. Okay, so that's what we are going to do. But first, before proceeding, we need to find the vectors v1 and v2 that are parallel to line L1 and L2, because we can't make any calculations with the parametric using the parametric equations of the lines. First, we have to find the vectors that are parallel to these lines, and then we make the calculations using these vectors. So vector v1 that is parallel to L1, it's equal to what? So vector v1 is equal to what? Vector v1 is parallel to L1, and it is equal to what? It's equal to 2a sub x plus 4a sub y plus 3a sub z. Okay. Of course, we mentioned that the parameters alpha and beta are real valued parameters. They could be any real number. Okay, we can assume them 1, 2, whatever you want. Okay, but for the vector, we take the coefficients of these parameters. Now, this is for vector v1, and now for vector v2, which is parallel to L2, it's equal to what? A sub x plus 3 a sub y plus 2a sub z. Okay, now we have the two vectors and we should make the cross product now between v1 and v2. So v1 cross v2 is equal to what? v1 cross v2 should be equal to a sub x, a sub y, and a sub z. v1 is equal to 2, 4, 3, and v2 is equal to 1, 3, and 2. And we take the determinant. This is equal to what? A sub x, 8 minus 9, minus a sub y, 4 minus 3, plus a sub z, 6 minus 4. Okay, this is equal to minus a sub x minus a sub y plus 2a sub z. So the result of the cross product is not equal to 0. So we can say that the angle between vector 1 and vector 2 is not 0. And so v1 is not parallel to v2. Okay, so as long as the two vectors are not parallel, this means that L1 is not parallel to L2 as well. Okay. Right. Number 2, we want to decide if the two lines are orthogonal. What orthogonal means? Means if the angle between them is equal to 0. So we want to find out if the angle between the two lines is equal to 0. Again, we will use the two vectors v1 and v2 to make the calculations and decide decide if the angle between the two lines is 90 degrees. To find out if the angle is 90 degrees, what should we do? We should use which kind of product? We should use the dot product, because if the angle between the two lines is 90 degrees, then the dot product should give me a result of 0. If it gives me a result that is not 0, then we can say that the two lines are not orthogonal. Okay, so then so we want to perform the dot product between v1 and v2. This is equal to what? 2 times 1 plus 4 times 3 plus 3 times 2. And this should be equal to what? 2 plus 12 plus 6, which is equal to 20. This is not equal to 0. And then we say that the two lines are not, then theta is not equal to 90 degrees. And we say L1 and L2 are non-orthogonal. Okay. Now, the third thing we want to find out is we want to decide if the two lines intersect or not. Okay. Number 3, do L1 and L2 intersect? Okay, so let's put the results we have gained here, put them aside. So we found that L1 and L2 are not parallel, and we found that L1 and L2 are not orthogonal. And now we want to find if they intersect or not. Okay. Okay, if two lines intersect, then at the point of intersection, let's use colors for this. Let's use for L1, use this green color. And for L2, use this orange color. Okay, now if these two lines intersect, then there is a point of intersection where this point lies on both of the lines. Okay, so this point, the point of intersection, should satisfy both the equations of L1 and the equations of L2 at the same time. Okay, the point of intersection lies on both of the two lines. So this point should satisfy the equations of L1 and L2 at the same time. Okay, so we don't know the coordinates of this point. So we use it as a variable, okay? And then we try to find the values of these variables. So this point should let's say let's call the coordinates of this point on L1 as x1, y1, and z1. And this same point lies on L2, so it should take the coordinates x2, y2, and z2. Okay, so at the point of intersection, okay, x1 should be, okay, let's write this first. At the point of intersection, we have x1 to be equal to x2, and y1 to be equal to y2, and z1 to be equal to z2. Okay, so let's take the values of x1 from here. So x1, which is 4 plus 2 alpha, should be equal to x2, which is 2 plus beta. And we have the other equation, which is y1 should be equal to y2. So we have y1 from here, which is minus 5 plus 4 alpha should be equal to minus 1 plus 3 beta. Minus 1 plus 3 beta. So we have two variables, which are alpha and beta, and we have two equations. So we can get rid of one variable and keep the other. So let's call this equation 1 and this equation 2. What we need to do is multiply equation 1 by minus 2 times equation 1 plus equation 2. So what we get is minus 8 minus 5 is equal to minus 4 minus 2 beta minus 1 plus 3 beta. Okay, we have minus 13 plus 4 is equal to minus 9 plus 1 minus 8. Minus 8 should be equal to what? To beta. So at the point of intersection, beta is equal to minus 8. And let's find alpha. 2 alpha is equal to 2 minus 4 plus beta. So 2 alpha should be equal to minus 2 minus 8, which is equal to minus 10. So alpha is equal to minus 5. Okay, now we found beta and alpha at the point of intersection. If there is a point of intersection, then we should substitute for alpha and beta at the equation of the Z1 and Z2, if the substitution of alpha and beta achieves this equation, let's call it equation number 3, if we use these values of beta and alpha in equation 3 and equation 3 is satisfied, then we say that the two lines do intersect. There is a point of intersection between line L1 and L2. But if these values of beta and alpha do not achieve equation number 3 here, then we say that the two lines do not intersect. Okay, there is no point of intersection between the two lines. So the equations for the Z1 and Z2, Z1 is equal 1 plus 3 alpha, and we have Z2 is equal to 2 beta. So this is equation number 3. Let's substitute for the values of alpha and beta we just found, this, and see if the equation is satisfied. So 1 plus 3 alpha, 3 times minus 5, is it equal to 2 beta, which is 2 times minus 8. So 1 plus minus 5 minus 15 is equal to minus 14. Is minus 14 equal to minus 16? No. Then equation number 3 is not achieved. Okay, and this means that the two lines do not intersect. There's no common point between the two lines. Okay, so our assumption that there is a point achieving the equations of both L1 and L2, this assumption is not correct. Okay, so the values of beta and alpha do not satisfy equation 3, and therefore there is no point, there's no point of intersection between L1 and L2. Okay, so let's put the result here, the new result here. So the new result is that L1 and L2 do not intersect. Okay, so the thing we need to find out, which is in number 4, are L1 and L2 secure? Are they secure? For us to find out, for us to decide if the two lines are secure, we need to say we need to make sure that the two lines are not parallel and they don't intersect. Let's look at the results we have just found. We found that the two lines are not parallel and the two lines do not intersect. Okay, so these are the conditions we want to prove that the two lines are secure. So the first thing, that the two lines are not parallel and the two lines do not intersect. These two conditions are required to decide that the two lines are secure. So L1 and L2 are not parallel. L1 and L2 do not intersect. So therefore, we decide that L1 and L2 are secure. Okay. the orthogonality here is not a condition for skew, to decide if the two lines are skew or not. Only if they're parallel or not, and if they intersect or not. So the two lines L1 and 2 are skew. Okay. Okay, let's do this example before we stop. This example is asking us to determine whether or not this example is asking us to determine the distance between two skew lines. So it's giving us two lines, L1 and L2, and it's telling us that these two lines are skew. So we don't need to prove that the two lines are skew. It's telling us already that these two lines are skew. But the question is that how to find the distance between these two skew lines, okay? Of course, the distance, again, the distance between these two skew lines should be orthogonal to each of the two lines. So this distance, let's say this is L1 and this is L2, D should be perpendicular to L1 and it should be perpendicular to L2. Okay. Now to find the distance between the two lines, what we need to do is that we want to assume a point P. Let's say this is L1 and this is L2. Okay, we want to assume a point P on line L1, and we give this point the coordinates 1 plus alpha and 2 alpha and minus 1 plus 2 alpha. Okay, and we assume another point Q that lies on L2. The coordinates of Q are 2 beta, 3 plus beta, and minus 1 minus beta. Okay. After getting these 2 points, we want to form a vector between these two points. We call it vector P Q. It's a vector that goes from point P to point Q. Okay. The vector PQ is equal to what? Is equal to the coordinates of Q minus the coordinates of P, which is equal to 2 beta minus 1 minus alpha A sub X plus 3 plus beta minus 2 alpha A sub Y plus minus 1 minus beta plus 1 minus 2 alpha A sub Z. Okay. Okay. So here minus beta minus 2 alpha. Minus beta minus 2 alpha A sub Z. Okay. Now this vector PQ, it should be normal or perpendicular to L2. At the same time, it should be perpendicular to line L1. Okay, so we form a vector that is parallel to L1, vector V1, that's parallel to L1, and it's equal to what? From here, the vector V1 is equal to A sub X plus 2a sub y plus 2a sub z. Okay, and we also want to find another vector v2 that's parallel to L2. So this is v2. v2 is equal to what? 2a sub x plus a sub y minus a sub z. Okay, now we have the two vectors v1 and v2. Now the last thing we want to do is we want to perform the dot product between the vector pq and v1, and then we perform the dot product between pq and vector v2. Both of the dot products should be equal to 0. Why? Because the angle between the vector pq and v1 is 90 degrees, and the angle between pq and vector v2 is 90 degrees. Okay, so we have two equations which are pq dotted with v1. It should give us 0. This is equation number 1. And we have pq dotted with v2. This should give me 0 as well. This is equation number 2. Okay, now we solve for the two equations. We have two variables. We have two variables, beta and alpha, and we have two equations to solve them, equation 1 and equation 2. We solve for alpha and beta, and we find the values of alpha and beta, and after we find the values of alpha and beta, we substitute for beta and alpha here, and then we find the vector. We find the value of the vector PQ, and then the distance D, which is the shortest distance, should be equal to the magnitude of the vector PQ. Okay, I want you to finish this, solving this example by yourselves, and if you have any problems, you get back to me, inshallah, next week. Okay, but this is the procedure you need to go through. The final answers are there. Okay, so you should get this value of the distance. Okay, I stop here, and I'll see you next week, inshallah. Assalamu alaikum.